Students, I welcome you all. Myself, Dr. Dhiren Kumar Shukla, Associate Professor in the Department of Engineering Mathematics at Technocrats Group of Institutions. Today, we are going to discuss about ordinary differential equations, part 1, which is a unit in Engineering Mathematics level 1. So, first we start by the definition. What is differential equation? So, differential equation is a topic in which an equation consists derivatives. So, when we talk about derivatives, means there should be an independent variable and an dependent variable. So in case of differential equations, in equation there could be more than one dependent variables, more than one independent variables. There are type of equations. So in general, when we talk about the differential equation, so we say that an equation containing a dependent variable and an independent variable and derivatives is called differential equation. So you can see here the example. Then next is order and degree. What is order and what is degree? When we have an equation where we have independent variable and dependent variable, then how many times the equation is differentiated is called order, and what is the power of the derivative of highest derivative is called degree. So here you can see the equation is d2y over dx2 minus dy over dx whole cube plus y equal to sin x. So you can see here the highest derivative is here d2y over dx2. So order is 2 and the power of this particular term is 1. So degree is 1. Then linear and non-linear differential equation. When we talk about linear equation, so the power of derivative and its dependent variable should be 1. For example, the first line d2y over dx2 minus dy over dx plus y equal to cos x. And in the second example, you can see here d2y over dx2 plus 2y by 3x minus 2y square. So you can see here the dependent variable is y and this power is 2. So that is non-linear. So in this way we can determine linear and non-linear differential equation. Formation of differential equation. For example, we have a question like here y equal to a cos log x plus b sin log x. Then we have to differentiate this equation with respect to x. So by using the formula of product of differentiation. So dy by dx, after implementing the process which you have already studied in your school level at 11th class or 12th class. So you can see here at the last the expression is x square d2y by dx2 plus x dy by dx plus y equal to 0. So in this way we can create a differential equation from a given equation. Solution of first order and first degree differential equation. So what it means, when we have an equation where order and degree both are 1, there is order of equation is all 1 and degree is also 1. So such kind of equation is called first order first degree. In the way of presentation we can write it dy by dx equal to f of xy. There are some methods to solve such type of cases. The first method is variable separable method, second is linear differential equation known as Leibniz equation, third is non-linear differential equation known as Bernoulli's equation, and fourth is exact differential equation. So variable separable method, suppose we have a structure like that f1x dot g1y dx plus f2x g2y dy equal to 0. After making some arrangements like mathematical operations, and then we get an equation like here integration f of x dx plus integration f of y dy equal to c. So you can see here the variables are distributed according to their integral part. In case of dx there is function in x, in case of dy there is a function in y. So such case is called variable and separable method. For example, we have a question dy by dx equal to 1 plus x plus y plus xy. So how can we solve it? So dy by dx equal to the next part of the equation. Then we have to distribute the terms according to dy and according to dx. So we can get it dy over 1 plus y equal to 1 plus x dx. After making the integration, we can see here log of 1 plus y is equal to x plus x square by 2 plus c. C is the constant part we use in integration. So there is another form of equation, linear differential equation, known as Leibniz equation. So a equation in the form of dy by dx plus py equal to q, where p and q are functions of x or constant. So in this case, we have to find out first integrating factor. It is written as I dot f dot. So the formula is e to the power integration p dx, and the solution of in this case is y dot if is equal to integration q dot if dx plus c. So for this case, we have an example. So the solution is here, dy by dx plus 2x upon 1 plus x square dot y is equal to cos x upon 1 plus x square. So we can see the p and q both are functions of x only. So the if is e to the power integration p dx. So first we need to create the integration part. So integration 2x by 1 plus x square dx, by taking 1 plus x square is equal to t, dt is equal to 2x dx. Then put the values in the formula. So if is equal to e to the power log 1 plus x square is equal to 1 plus x square. As we know that e to the power x is equal to e to the power log x is equal to x, the formula. So by putting the value, we can see here y dot 1 plus x square is equal to sin x plus c. So another part is non-linear differential equation, known as Bernoulli equation. The equation is dy by dx plus py equal to q times y to the power n, where n is not equal to 1. So it is not 0 and 1. So it's called Bernoulli's differential equation. So how to solve this kind of equation? So we consider v equal to y to the power 1 minus n, dv by dx is equal to 1 minus n, y to the power minus n, dy by dx. So in this way we can get the value in the terms of v. So we put the equation value in the equation. So we get another equation dv by dx plus p times n minus 1 v equal to q times n minus 1. So this is another form of again it is converted in the Leibniz form. So now we have a question x dy by dx plus y is equal to x cube y to the power 6. So we can see here in right hand side the y is in the power of 6. So first of all we have to divide the equation by y to the power 6, or we can say we have to multiply the equation by y to the power minus 6. So here after making the process, we get y to the power minus 5 is equal to v. After making supposition and distribution process, we can see here in the last line minus 1 by 5 dv by dx plus v by x is equal to x square. So now we can proceed according to the rule of linear equation, Leibniz linear form. So p is minus 5 by x, q is minus 5x square. So by getting if is 1 by x to the power 5, and then put the values in the formula. So here exact differential equation, a first order differential equation of the form m dx plus n dy equal to 0, where m and n are functions of x and y both. In this case, if del m by del y is equal to del n by del x, then it is called equation is exact. So here the symbol del is denoted for partial differentiation. So here you can see the formula to find the value. Integration m dx y constant plus integration n dy terms free from x equal to c. By putting the values here, we can get the answer. So here is an example: 1 plus 4xy plus 2y square dy plus 1 plus 4xy plus 2x square dy. So first of all, we have to find out m and n separately, getting the value del m by del y and del n by del x. We can see here the equation is exact. So in this case, we have to put the values in the formula. So integration y constant m dx plus integration n dy terms free from x. So you can see here in case of m, you have to put all the part, but you have to take y as a constant. In case of n, you have to keep only those terms which does not have x. So you can see here it is written that 1 plus 4xy plus 2x square. So symbolically the two terms 4xy and 2x square is cut here just to show that we don't need to take these terms in n. So you have to take only those terms we do not have x. So by making the integration we can get the solution. There is another way of solution, that first we have to find out the integration m dx by taking y constant and integration n dy by taking x constant. And then after making the solution, you have to keep the repeated terms once only, and in addition the rest of the terms. So by this you can get the solution x plus 2x square y plus 2xy square plus y, and the constant term is c. Now, if the equation is not exact, that is del m by del y not equal to del n by del x. In this case, where we have some cases, so according to cases we have to make the equation first exact, then we need to proceed for the solution. So there is first case. So first case is that m dx plus n dy equal to 0, and in this case if the equation is homogeneous and mx plus ny not equal to 0, then integrating factor is 1 by mx plus ny. So how we proceed the question? And the second rule is, if m dx plus n dy equal to 0, and here the condition is that we can keep the y common in the m part and we keep the x common in the n part, and where mx minus ny not equal to 0, then if is equal to 1 upon mx minus ny. So actually these two cases go simultaneously. In one case mx plus ny, in one case mx minus ny. So we study in the collaborative. So the question is that xy minus 2y square dx minus x square minus 3xy dy equal to 0. So first of all we have find out the mn separately, find out the partial derivative, that so del m by del y is not equal to del n by del x. So here you can see the given example is homogeneous. Homogeneous means that power of total term is equal. For example, the first term is x square y. So the power of x is 2, power of y is 1. In total it is 3. In the next term, the power of x is 1 and power of y is 2. So again it is 3. In the same way you can check in the rest of the terms. So in this case, we have to find out the condition of mx plus ny. So multiply m with x and with y, and you will get mx plus ny not equal to 0, and so if becomes 1 by xy square. Multiplying the if with the equation, we get another differential equation, and now which should be exact. So find out m and n separately and get the value of del m by del y and del n by del x. Now you can see these values are same. When you get the exact condition, then you have to follow the formula. Integration m dx y constant and n dy terms free from x. By putting the values, you can see here the rest of the part is x by y plus log y cube by x square. So this is the simple example. And now another rule, 1 by n del m by del y minus del n by del x, only function of x or constant. In this case, first we have to find out the partial derivatives, then make subtraction in between them, then check whether it is differentiable by n and it is giving the only x part, means the function of x only or constant. In this case the integrating factor will be e to the power integration f of x dx. In the same way, another rule is that you have to find out the del n by del x minus del m by del y and check whether it is differentiable, it is divisible by m, and it gives the function of y only or constant, then if is equal to e to the power integration f of y dy. So one example is here, dy by dx is equal to x square plus y square plus 1 upon 2xy. So first of all rearrange the equation according to the structure, then after getting the solution del m by del y, del n by del x, both are not same, so equation is not exact. Then consider del m by del y minus del n by del x divided by n. So you get the value minus 2 by x, which is function of x only. So by this way we get the if. So it is 1 by x square. Once you got the if, then multiply the equation by if. So you get another equation which should be exact. So you can see here del m by del y equal to del n by del x, that is 2y by x square. So once the equation is exact, so again apply the formula integration m dx y constant and integration n terms free from x. You can see in place of n, that is there is 0. So why it is 0? Because there is no terms free from x. Clear? So symbolically again it is written here 2y by x. So we cannot take 2y by x because this term has x. So you have to take the terms only in n which is free from x. So in this way again we can get the solution x square minus y square minus 1 equal to cx. So now go for solution for first order and first degree differential equation. So here structure is a naught dn by dx and y plus a1 dn minus 1 dx and minus 1 y up to a and y. By taking y is in common, so you can see here y times this equal to q. Put the d by dx is equal to symbolic capital D and so on. Dn by dxn is equal to d to the power n. So the given equation in first term can be written as f of dy is equal to q. This is the simplification of the first line. Now the solution of the expression should be y equal to cf plus pi. Cf stands for complementary function and pi stands for particular integral. So when we get cf only, when we get pi only, it depends upon the right hand side of the equation. If right hand side of the equation is 0, then you have to get cf only, and if in the right hand side is there any function, so you have to keep cf and pi both. So f of dy equal to q, then find auxiliary equation. To get auxiliary equation, we have to put d equals to m, y equal to 1 and consider q equal to 0. Then we get the roots like m1, m2, m3 and so on. So according to the nature of roots, we have several formulas. Like first condition is when roots are real and distinct. So in this case the formula will be c1 e to the power m1x plus c2 e to the power m2x up to cn e to the power mnx. Means you have to create the terms according to the number of individual roots. The second formula, it depends upon the repetition of the roots. Means roots are real and equal, or you can say real or repeated. So here number of roots are repeated. According to that we have to create the terms. Like two roots are repeated, then we can say c1 plus c2x e to the power m1x. Now then more roots are repeated, so we can arrange them accordingly. You can see here another way of presentation. Here you have three roots are repeated, like c1 plus c2x plus c3x square e to the power m1x, and in the same way you can create other terms. So next formula for imaginary. When we go for imaginary roots, so always it should be in pair. Means one term will be in plus sign and one term will be in minus sign, alpha plus minus I beta. So in this case you have to formulate like e to the power alpha x c1 cos beta x plus c2 sin beta x. So these are the presentation of formula. And the imaginary roots are real and equal. Sorry, imaginary roots are equal. In case we have imaginary roots but they are also repeated, so how can we determine them? So e to the power alpha x c1 plus c2x cos beta x plus c3 plus c4x sin beta x. In this way we can create the formula. Then the next case is roots are surgical, means irrational numbers. So when roots are irrational numbers, so you can create it as a form of first case, because rational numbers also a part of real number, but you can determine in another way also in case of hyperbolic. So either you can say write c1 e to the power alpha plus root beta x, c2 times e to the power alpha plus root beta x. Otherwise cf is equal to e to the power alpha x c1 cos hyperbolic beta x plus c2 sin hyperbolic beta x. So this is the way of presentation. Then we have a question. So according to question, first we have to create equation in the form of d. So that is d square plus 3d plus 2y equals to 0. So create auxiliary equation, put d equals to m, y equals to 1 and consider q equals to 0. So you get the value of m is equal to minus 1 and minus 2. So the CF part becomes c1 e to the power minus x and plus c2 e to the power minus 2x. So in this case we don't need to go for pi because right hand side is 0 only. Now particular integral f of dy equal to q when q not equal to 0. So when q equal to e to the power x, this is a special case of exponential. In this case you have to put the value of a. A means in the exponent of e the coefficient of x. So you have to put that value in place of d. So and you have to check that f of a should not be 0. So if f of a is not 0, then 1 by f of here one misprint is there. If f of a equal to 0, so you have to consider it f of a not equal to 0. Clear? So pi is equal to 1 by f of d e to the power ax. So put in place of d the value of a, and then you have to follow the condition. Clear? And when the equation becomes f of a equal to 0, so it is a failure of the case, and in this case you have to go for the first rule, which we will study in upcoming slides. So you can see if f of a equal to 0, then another method is 1 by f of d e to the power ax. So in this case you have to create the term e to the power ax x dot 1 by f d power as f prime d equal to 0. So pi is equal to x dot 1 by f d e to the power ax. So it becomes x square 1 by f double prime d e to the power x. By continuing this process, we get pi is equal to x to the power n plus 1 by f of n up to n prime d e to the power ax. Clear? So this is the formulation. So the question is d2y by dx2 minus 5 dy by dx plus 6y is equal to e to the power x. So to solve this question, we have to first put d equals to m, y equal to 1, and consider q equal to 0. So the values are m equal to 3 and 2. So the complementary function is cf is equal to c1 e to the power 2x plus c2 e to the power 3x. Then to find pi, that is pi equal to 1 by f of d e to the power x. So you can see here the coefficient of x is 1 only. So you put the value of a, means the coefficient of x, in place of d. So that is minus 1 by 2 e to the power ax. So final solution will be y is equal to cf plus pi. So another question is d square minus 2d plus 1 y equal to e to the power x. In the same way, first we have to create auxiliary equation. So here you get the value of m is 1 1. Then complementary function becomes cf is equal to c1 plus c2x e to the power x. You can see here two roots are repeated, means one is repeated two times. So c1 plus c2x e to the power x. Then to find pi, 1 by d square minus 2d plus 1. Again the value of a is 1. A is coefficient of x. So put the value of that and we get the solution here, because f of, when we put f of 1, so it becomes 0, means it is the failure of the method. So we have to go another method so f prime d is equal to 1 by 2d minus 2 ex f. Then f prime 1 is equal to x dot 1 upon 2 minus 2 e to the power x. So again f prime 1 is equal to 0. So we have to find out f double prime. So here we get 1 by 2 e to the power x dot x square. So pi is equal to 1 by d minus 1 square, f of d plus a is equal to, and so on. By following this process, finally you will get the pi, that is e to the power x times x square by 2. So y is equal to cf plus pi. You can write the answer separately, the value of cf plus value of pi. Another rule is for q equal to sin ax and cos ax. In case of sin and cos, you have to be very much particular about sign property. So when you have the term sin, so you have to keep the value of a square and then put minus. There is very big difference between minus a square and square of minus a. So you have to first create the square of a, then you have to put minus. So this is the formula. And there is another case also, 1 by f of d square plus a square cos ax is equal to x by 2a sin ax, and f1 by f of d square plus a square sin ax is equal to minus x by 2a cos ax. Now go for the question. This is the question. So first you create auxiliary equation by putting the value of d, y and q. So the value of m is 1 and 2 times minus 1, means 1 is real and minus 1 is real and equal. So in this way we can create the CF, C1 e to the power x and C2 plus C3x e to the power minus x. Then go for PI, and in case of PI, 1 upon d square plus d plus 1 minus 1 times d plus 1. So in case of d square, you have to put minus times 2 square. The value of a is 2. So by doing this process, we get minus 1 by 5 times 1 upon 1 plus d cos 2x. Now in denominator there is 1 plus d. So now we go for the rationalization process. It is called in Hindi, that is called Parimeekaran. So you have to make rationalization. So multiply 1 minus d upon 1 minus d. So again in denominator we get the d square. Means you can put the value of a in case of sine and cos when the power of d is even at least 2 and then higher than 2, 2, 4, 6, 8 and so on. You cannot put directly in the odd number 1, 3, 5, 7. You have to first segregate the even power separately and odd power separately. So by doing this process, we get this solution minus 1 by 25 cos 2x minus d cos 2x. So d means differentiation. You have to differentiate in numerator part. So finally you will get y equal to CF plus Pi. So there is another case q equal to x to the power m dot where m is positive integer. So formula 1 by f d x to the power m f upon 1 upon f times 1 plus minus d x to the power m. So 1 plus minus phi of d to the power minus 1 x to the power m. Here we use the formula of binomial. So 1 minus x inverse, 1 plus x inverse, such type of formula you have already studied in school level. So just memorize that and follow and use in the examples. So example is that d square plus 4y times is equal to x square. So auxiliary equation is m square plus 4 is equal to 0, m is equal to plus minus 2i, which is a case of imaginary. So here the value of alpha is 0. So you can create CF e to the power 0x, c1 cos 2x plus c2 sin 2x. Then pi 1 by d square plus flow x square. So in denominator you have to create 1 plus and 1 minus like of term. So you have to keep 4 as a common. So we get 1 minus d square by 4 to the power inverse. Then by making binomial expansion, there is 1 minus d square by 4 plus d 4 by 16 and so on. So you have to keep 2 to 3 terms and you have to then left the rest of the terms according to the requirement of the equation. Just like here we have the part x square. So x square cannot be survived after d square also. So you have to keep only 2, 3 terms. So by multiplying x square, we can get here 1 minus 1 by 4 times 1 minus d square by 4 x square. Then distribute the x square inside the expression after doing differentiation process. Finally, you will get the 1 by 8 and times 2x square minus 1. So the final solution is equal to y is equal to CA plus Pi. So another rule is q is equal to e to the power ax dot b, where b is a function of x. So formula is pi is equal to 1 by fd e to the power x dot b. So in case of e to the power x dot b, first you have to keep e to the power x towards left side and put d plus a in place of d in denominator f of d, and then after the nature of b you have to apply the formula. Like in this case, the question is d square minus 2d plus 1 y is equal to e to the power x dot x square. So auxiliary equation is m square minus 2m plus 1, and by creating the solution you get m is equal to 1 1, which is a case of repeated. So CF becomes C1 plus C2x e to the power x. Then to get pi, 1 by d square minus 2d plus 1 e to the power x x square. So here the value of a is 1, so you have to put in place of d plus 1. After putting and solving this, you get another denominator, that is 1 by d square. In case of 1 by d, it means integration. So how many times the d is repeated in denominator means according to the power you have to make the integration that particular number of times. So here it is 1 by d square, means you have to integrate it is 2 times. So after integration 2 times, we get the solution e to the power x to the power 4 by 12. So this is your again answer, y is equal to CF plus Pi. Another rule is q is equal to x dot v. V is a function of x. So Pi is equal to 1 by fd x dot v. In this case again there is a specific formula. Pi is equal to x dot 1 by fdv, f prime d upon fd whole square dot v. So there is a question d square minus 2d plus 1 y is equal to x to the power minus x. So auxiliary equation m square minus 2m plus 1. Here by getting the value of n, the CF is C1 plus C2x e to the power x. Then Pi becomes 1 upon d square minus 2d plus 1 x times e to the power minus x. According to formula we have to distribute it. So e to the power minus x dot v. So method 1. Then we have to put in place of d minus 1, and by making the solution you will get the answer. So here e to the power minus x by 4, 1 minus d square by 4 whole inverse x. Then again, by using the binomial, you can get the solution and distribute the x inside the expression. So you will get y is equal to CF part plus PI part. So again here, PI is equal to 1 upon d square minus 2d plus 1 e to the power minus x. So in this case, you have to distribute x in towards left hand side. Then you have to keep the solution according to given procedure. We have already discussed in the previous slides. So follow these steps and you will get the solution of y equal to CA plus PI. These are some examples for practice purpose. So you can use these questions, and according to the mentioned rules and definitions and properties in the slides, you can follow and you can solve the questions. So dear students, this is all complete tutorial for the given content in your unit. So that's all for today. Now we will meet in next lecture. Thank you.